In this video, we're learning how to solve linear systems by a method that's called elimination. So remember that when we're trying to solve a system, we're trying to figure out where the two lines cross. So we're trying to figure out an XY coordinate pair that represents where the two lines cross. So we're going to get two answers. When we solve these, we're going to get an X value and we're going to get a Y value. So if we look at our first problem, we have the lines 3x plus 4y equals 9 and negative 3x minus 2y equals negative 3. So when we're using this method called elimination, our goal is to eliminate one of the variables in both equations so that we're just left with one equation with one variable, and that'll be pretty easy to solve. So if we look at number 1, we want to notice that the first equation has a positive 3x and the second equation has a negative 3x. So they have very similar x terms, but the coefficients, the numbers in the front, are opposites. And that means that it's going to be really easy to solve this system using elimination. So what we want to do is we just want to add the two equations together. So we're just going to add straight down. So I'm going to put a plus sign here. And what's going to happen is when we add 3x plus a negative 3x, those are going to cancel each other out and go to 0. So we're going to get a 0 for our x terms. If we have a positive 4y plus a negative 2y, that's going to give us a positive 2y. And a positive 9 plus a negative 3 is going to give us a positive 6. So now we really have this equation, 2y is equal to 6. So we have one equation with one variable, which is pretty easy to solve. So now we're going to solve for y. So we're going to divide both sides of our equation by 2. And we're going to get that y is equal to 3. So that's the first part of our answer. But remember, we're always going to need two answers for this problem. We need to get a y value and an x value. So now we need to think, how can we find the x value if we have the y value? Well, we have two equations that relate x and y, so we can pick one of them and use it to solve for x. I'm going to pick the first equation because it doesn't have negatives. So I'm going to rewrite it down here. I know that 3x plus 4y is equal to 9. And I also know that y is equal to 3. So to solve for x, I'm going to take my y value I just found, plug it in for y in one of my equations. So I'm going to have 3x plus 4, and then I'm going to plug in my y value of 3, so 4 times 3 is equal to 9. And now I have one equation with one variable. So I have one equation with my variable x, so now I can solve for x. So now I'm going to simplify, so I have 3x plus 4 times 3 is 12 is equal to 9. And now I want to solve for x, so I'm going to go over here because I'm running out of space. So we have 3x plus 12 equals 9. I need to subtract 12 from both sides of my equation. On the left side I have 3x, and on the right side 9 minus 12 is negative 3. And finally divide both sides of my equation by 3. And I get that x is equal to negative 1. So my answers are x is equal to negative 1 and y is equal to 3. And sometimes some teachers want you to write this as a coordinate point because remember, we're trying to find where the two lines cross. So you could also write your answer as negative 1, 3. Let's take a look at example 2. So in example 2, we have 4x minus 3y equals negative 10, and we have negative 16x plus 7y equals 30. So this time we don't actually have two terms that are opposites, right? In number 1 we had a 3x and a negative 3x, but we don't have anything like that in example 2. The good news is we can still use elimination. We're just going to have to do one more step. So what we need to do is turn two terms into opposite terms. So if we look at our x terms, we have 4x and negative 16x. We can easily turn a 4x into a positive 16x, right, into the opposite by just multiplying by 4. So that's what we're going to do. But remember, anything we do to one term in our equation, we have to do to all the other terms. So down here, I'm going to show you how we can manipulate the first equation. So we're going to multiply the entire first equation by 4. So we're going to have 4 times 4x minus 3, and we're going to multiply the right side by 4. So 4 times negative 10. So what's going to happen is if we distribute this 4 out, we're going to get 16x minus 12y on the left side, and we're going to get negative 40 on the right side. So now we just turned our first equation into 16x minus 12y equals negative 40. And it really is the same line because we multiplied both sides by the same number. We just manipulated it to look a little different. So now I'm going to take our second equation and write it right underneath. So we have negative 16x plus 7y is equal to 30. And now we have a positive 16x and a negative 16x, so we can eliminate our x terms by adding down. So when we add 16x minus 16x, we're going to get a 0 for our x's. If we add a negative 12y plus a 7y, we're going to get a negative 5y. And on the right side, if we add negative 40 plus 30, we're going to get negative 10. So now we have negative 5y is equal to negative 10. And we can solve for y by dividing both sides of our equation by negative 5. And we're going to get that y is equal to positive 2. So that's one of our answers, is that y is equal to 2, or that's half of our answer. And now we have to find the x value. So over here on the right, remember we can take either equation. So I'll just take the top equation, which is 4x minus 3y is equal to negative 10. And we're going to replace y with the y value we just found. So we're going to have 4x minus 3 times 2 equals negative 10, and now we can solve for x. So we have 4x minus 3 times 2 is 6 equals negative 10. I'm going to add 6 to both sides of my equation. I'm left with a 4x on the left side. On the right side, negative 10 plus 6 is going to give me a negative 4. And if I divide both sides of my equation by 4, I get that x is equal to negative 1. So I get an answer of x is equal to negative 1 and y is equal to 2. And again, we can write this as a coordinate point, negative 1, comma 2. Let's go through some more examples. So example 3 is negative 3x minus 2y is equal to negative 1. That's our first equation. And our second one is 5x is equal to negative 4y plus 5. So again, we don't have two terms that are opposites. And also our two equations aren't perfectly lined up. So our first equation has x and y on one side, and our second one only has an x on one side, and then a y and a constant on the other. So what I actually want to do first is just rewrite the second equation so it's in the same form as the first. So I'm going to add 4y to both sides. So it's going to be 5x plus 4y is equal to 5. It's going to make it easier to eliminate because we want to add down, so we want everything to be lined up. And now we need to think if it's going to be easier to get our x terms to be opposites or our y terms. Well, 3 doesn't go into 5, so it's going to be a little bit trickier to turn our x's into opposite terms, but 2 does go into 4. So it's going to be easier to make our y terms opposite this time. So what we want to do is we want to take our second equation, negative 3x minus 2y is equal to negative 1. And we want to think, how can we turn a negative 2y into a negative 4y so that it can easily eliminate with this positive 4y? Well, we can just multiply it by a positive 2. But anything we do to one side, we have to do to the other. So we're going to have to multiply the right side by 2. If we distribute the 2, we're going to get negative 6x minus 4y is equal to negative 2. And now I'm going to write our second equation under it. So 5x plus 4y is equal to 5. And now I'm going to eliminate by adding down. So negative 6x plus 5x is going to give me a negative x. Negative 4y plus 4y is just 0, so x plus 0, or sorry, negative x plus 0. And negative 2 plus 5 is going to give me a positive 3. So I have negative x is equal to 3. And we just have to get rid of this negative, so we're going to divide both sides of our equation by negative 1. On the left side, we're left with x, and on the right, we get negative 3. So we get that x is equal to negative 3. And now what we want to do is take either equation, and we're going to plug in negative 3 for x and solve for y. So I'll take our top equation, so I have negative 3x minus 2y equals negative 1. And I'm going to replace x with our x value of negative 3. And now I want to solve for y. So negative 3 times negative 3 is positive 9. So I have 9 minus 2y equals negative 1. I'm going to subtract 9 from both sides of my equation. So I'm left with negative 2y on the left, and negative 1 minus 9 is negative 10 on the right. And finally, divide both sides of our equation by negative 2, and I get that y is equal to 5. So I get an answer of x is equal to negative 3, and y is equal to 5, which can also be written as the point negative 3, comma 5. So now let's take a look at example 4, which is a little bit trickier. So we have 2x minus 7y equals 3, and negative 3x equals 5y plus 12. And the reason this one is a little bit trickier is that 2 does not go into 3, and 5 does not go into 7. So it's hard for us to make our x terms opposites, and it's hard for us to make our y terms opposites. Luckily, we can still do it. It's just going to take an extra step. So what I first want to do is move the 5y in my bottom equation to make the x and y on the same side so it looks closer to the first equation. So I'm going to subtract 5y from both sides. I'll get negative 3x minus 5y equals 11. And now we just have to pick if we want to eliminate the x's or eliminate the y's. I'm going to pick the x's because the numbers are smaller, so it's going to be a little bit easier. And we're going to have to multiply both of our equations by some number. So I'm going to rewrite the first one. So we want to turn our x terms into the least common multiple of 2 and 3. And one's going to be positive and one's going to be negative. So we want to turn them into 6 and negative 6, because that's the least common multiple of 2 and 3. So I'm going to turn the first equation into positive 6 by multiplying everything by 3. So we'll multiply this side by 3, multiply this side by 3. And it's going to come out as 6x minus 21y equals 9. And then right next to it, I'm going to take the second equation, so negative 3x minus 5y equals 11. And I want to turn that into a negative 6. So I want to multiply both sides by 2. So that's going to turn into negative 6x minus 10y equals 22. So now I have a positive 6x and a negative 6x, so now I can eliminate. So I'm going to write the second equation under the first one right here. And I'm going to add down. So 6x minus 6x, or 6x plus negative 6x is 0. Negative 21y plus negative 10y is going to give me a negative 31y. And 9 plus 22 gives me 31. So now I have negative 31y equals 31. This 0 doesn't really matter. So I'm going to divide both sides of my equation by negative 31. And I get that y is equal to negative 1. So we got our y value, and now we have to get our x value. So again, we're going to take one of the equations. I'll just take the first one. So 2x minus 7y equals 3. I want to replace y with the y value I just found. So replace it with negative 1. And I'm going to solve for x. So I'm going to have 2x, and minus 7 times minus 1 is going to give me a plus 7. So 2x plus 7 equals 3. Subtract 7 from both sides. We're going to get 2x equals negative 4. Divide both sides by 2 to get that x is equal to negative 2. So I get y equals negative 1 and x equals negative 2 as my answer, which again can be written as the point negative 2 comma negative 1. So that's probably as hard as it's going to get with elimination unless your teachers decide to give you fractions, which we won't dive into today. But let's go through 2 more examples just to make sure that we've got it down. So for these last 2 examples, I encourage you guys to pause the video and try them on your own, and then you can watch me work through them to make sure that you've done them correctly. So for number 5, we have 6x minus 3y equals 0, and we have negative 9y equals 8 minus 14x. So first thing I'm going to do is manipulate the bottom equation by adding 14x to both sides so it looks more like the top one. So if I add 14x to both sides, I'll get 14x minus 9y is equal to 8. And now we want to think about if we want to try and eliminate the x's or the y's. So 3 can go into 9, so I'm going to eliminate the y's. So I want to turn negative 3y into a positive 9y. So I'm I'm going to take my first equation, and to turn a negative 3y into a positive 9y, I need to multiply by negative 3. So I'm going to multiply both sides by negative 3. And now if I distribute that negative 3 on the left side, I'm going to get negative 18x plus 9y. And on the right side, 0 times anything is 0, so I just have a 0. Now I'm going to take my second equation and write it underneath. And I'm going to add down to eliminate the y's. So negative 18x plus 14x is going to give me a negative 4x. 9y plus negative 9y is just 0, so I'll put plus 0. And 0 plus 8 is just 8. So now I have a negative 4x equals 8. And I'm going to divide both sides of my equation by negative 4 to get that x is equal to negative 2. And now we want to use that to find our y value. So I'll use our first equation. So 6x minus 3y equals 0. I'm going to replace x with the x value I just found, which is negative 2. So I have 6 times negative 2 minus 3y equals 0. And I'm going to simplify and solve. So 6 times negative 2 is negative 12. So I have negative 12 minus 3y equals 0. I'm going to add 12 to both sides. So I'll have negative 3y on the left, and I'll have a positive 12 on the right. And finally, divide both sides of our equation by negative 3. On the left, I'm left with a y, and 12 divided by negative 3 is going to give me a negative 4 on the right. So I get that y is equal to negative 4. We already found that x is equal to negative 2. So I can write this as a point, negative 2, comma, negative 4. So now let's go over our last example. So our last example is 7x plus 8y equals negative 9, and 4x plus 6y equals negative 8. So we can't easily turn 7 into 4 or 4 into 7, and we can't easily turn 6 into 8 or 8 into 6. So we're just going to pick one of the variables that we want to eliminate. I'm going to pick 6 and 8 because their least common multiple is 24, which is a little bit smaller than the least common multiple of 4 and 7, but it doesn't actually matter which variable you choose to eliminate for this one. So I'm going to turn the top equation into something with a 24y. So I'm going to take the top equation, 7x plus 8y equals negative 9. And to turn 8y into 24y, I need to multiply by a positive 3. So I'm going to multiply both sides of my equation by positive 3. On the left side, when I distribute that out, I'm going to get 21x plus 24y. And on the right side, negative 9 times 3 is negative 27. And now I'm going to take my bottom equation, and I want to turn 6y into negative 24y. So I have 4x plus 6y equals negative 8. I want to turn 6y into a negative 24, so I'm going to multiply both sides by negative 4. On the left side, when I distribute, I'm going to get negative 16x minus 24y, which is what I want. And on the right side, negative 8 times negative 4 is positive 32. And now I'm going to move my second equation under my first one so I can eliminate. So negative 24y equals 32. And I want to add down. So 21x plus negative 16x is going to give me a 5x. 24y plus negative 24y is 0, so 5x plus 0. And on the right side, negative 27 plus 32 is 5. So I really have 5x is equal to 5. And now I just divide both sides of my equation by 5. And I get that x is equal to 1. And finally, last step, we're going to take our x value of 1, plug it into either equation, and solve for y. So I'll take our first equation, so 7x plus 8y equals negative 9. I want to replace x with the x value I found, so replace it with 1, and I'll use that to solve for y. So 7 times 1 is 7, so I have 7 plus 8y equals negative 9. I'm going to subtract 7 from both sides, and that'll leave me with 8y on the left. And on the right, negative 9 minus 7 is negative 16. Divide both sides of my equation by 8. On the left, I'm left with a y. On the right, negative 16 divided by 8 is negative 2. So I get that y is equal to negative 2, x is equal to 1, and I can write that as the point 1 comma negative 2. So hopefully this video helped you guys learn how to solve linear systems by elimination. The key to elimination is that you have to make two of the terms basically the same but opposites. So you want to either pick the x or y terms and make the coefficients opposites, and then you want to add down so that you can eliminate that variable.